Hello. Good question has been brought up about angled mortise and tenons, and it partly involves real-world considerations of both the integrity of the joint, and it also involves, the question involves actual engineering or mathematical questions. I lack the academic engineering acumen to do the equations and quantify what I'm about to tell you, but what I say I know based on an everyday knowledge of practical engineering considerations. And I say that in light of 34 years of construction experience. And you can look at cabinet making and furniture making as just one trade in the whole construction field, all the way up to plumbers and carpenters and roofers and all these other things. So you could look at it in that light. I try not to, but it is one way to look at the trade of cabinet making and carpentry, that it's within the whole framework of construction. And in construction, you can gain practical knowledge without ever having the academic knowledge. But a great question comes up about an angled tenon. In an assembly like this, is this a practical joint? Will it perform over time, and can it break out on the acute side of the joint? If you look at, and I assume the question, I haven't seen the Peacock video that was brought up in the question, Mitch Peacock's video. I think I have seen it, but I'm not sure. But I actually think I have seen the video. But in any question, I hope I'm addressing the issue when I talk about the acute and obtuse. The acute is anything under 90. The obtuse is anything over 90 degrees. Well, to answer the question, though, about is a angled mortise and tenon practical? Well, if you look at how it was used historically, I'm going to come in a little closer here and see if I can make sure that I'm in frame. I'll zoom in a little bit and let me see. In fact, I think I'll just take the camera out and close up on the sketches I've done. Okay, let me just do it this way. If you look at a sketch such as this, and it's still not as bold as I should have done it probably, but historically in a structure, a building, if you had an angled member coming in to a vertical member, and you did an angled mortise and tenon, there were valid considerations, and it's probably from real world problems that it came about. There's valid considerations about where are the stresses and what are they going to do to this hole in this member. And if we look at the side of the joint, this side here is the acute side of the joint, if we could speak in those terms, and over here is an acute angle. And you have this member coming down, we have a tenon, and I think it matters, by the way, if it's a through tenon or not. I think the dynamics of it change probably if it is in fact a through tenon. It probably is better, but it would be perhaps more prone to problem if it's a partial tenon, stopping somewhere in the midpoint. But then other considerations come in about chopping hole all the way through a member, and to what extent do you weaken that member. So a partial hole might be good in some respects in not weakening this member by having a partial hole versus a through hole, which then potentially weakens this member. So I think there's several dynamics at work. But if you look at the structure with a vertical member and an incoming brace, let's say, picture a mortise and tenon building or barn or something. Well, it seems to me, from a practical standpoint, You have vertical forces and you have lateral forces. We never know what the wind's going to do and other forces at work that cause lateral forces. But we know there's some vertical forces just by its own dead load. It's the live loads that we worry about creating other angular forces as far as being even lateral forces. But it seems to me we have a consideration definitely for vertical forces, and as those forces come down on this brace, they transfer down this brace into this member, and to some extent though, those begin to become lateral forces. And that's where the question is, could this, if I could just draw it in, could this crack off and break out? And if this was a through member, could this force that's this way transfer into force over here that's this way, and then cause this acute angle to bust out? So those are question marks about what is the strength of this joint. And I think those are valid considerations on the mortise. Now what, if you could see this, what's often been done is a partial mortise, and then this has been flattened off. Now you're working on the strongest possible shear strength of the material. It's just not going to break off. Even though the tenon's been reduced, it still has a valid connection, but this bottom has been flattened off. And I think that's got to be known about the way a building was pinned together. And like I say, I don't have that much historical knowledge, or certainly don't have the academic acumen to do the equations to quantify what I'm saying, but I think the practical solution that I'm aware of was that this was flattened off. Now, if we took this whole thing and turned it more like my stool assembly, which, you know, is nowhere near that steep. You know, we're talking about a rail with a 6-degree shoulder in it, a vertical with a 6-degree tilt to it. Well, it's nowhere near these angles. These could be as high as 60 to 45 degrees. It could be 60 degrees or perhaps 45 degrees. And the more it gets horizontal, the better things get for the strength of the joint. So the more it goes beyond that is not a problem, but in this range that it's in is, I think, the question on this structure. But if we begin to turn this and begin to simulate what's happening in the stool, we see right away that the angles are so much different in the stool. They're more like this as compared to this. Now, what if I had an assembly like this? What if what I was building was not stools, but it was a pair of heavy-duty sawhorses? And I said, well, I went through tenons on it. Would I do that joint? No, I would not. Because I don't know how much force is applied here, which is now the vertical force, and not the lateral force. In this case, we have possible lateral movement in the building. We have downward forces, but potential for lateral forces. And we also have them down here, this way and this way, all due to vertical forces and perhaps live load or wind shear. So if we turn this assembly this way and begin to simulate my stool construction, well, this angle is too steep, or shall I say shallow. It's too acute, too much under 90 to work. So no, I wouldn't use this joint. If this was half of a sawhorse assembly, and I know force is going to be put here, perhaps a lot of force, probably not on sawhorses, but you know, we want sawhorses generally to hold about a pair of sawhorses to function well over a long period of time, I would suggest they probably need to be able to hold about 1,000 pounds. That's just a layman's guess. When you put that much force this way, this leg wants to bend really radically. And yeah, I think you'd break off the acute side of this mortise and tenon joint. It's possible. What I would then switch to is a half lap or some other type of joinery. Perhaps you could do with changing this angle just like it's done in the vertical application and use a pinned mortise and tenon. But definitely I wouldn't do a through mortise, and I would go as deep as I can go and perhaps flatten it. But I probably would opt for a whole nother set of thinking on that, a whole nother set of joinery, and that would probably be a half lap or some other type of joinery, not the mortise and tenon joinery. Now if we go back to the stool, it seems to me with a horizontal member and a fairly steep member this way, we still have vertical forces, and then we have racking forces or lateral forces that are probably never totally lateral but go on some type of angle. And it seems to me I'm so close, I'm only 6 degrees away from 90-degree connection there. It seems to me I have so much strength here and here that there wouldn't be any fear of it. And if it did fail, it would fail under such intense loads that this piece is not likely to ever get. You know, if this stool was taken and then used as shoring for a collapsing building, and a post was put on top of the stool seat and said, okay, this has now got to support 2,000 pounds or 5,000 or 10,000 pounds. Yeah, I think there's still a question here. But then haven't we exceeded the intent of the piece? You know, clearly though, when you have lateral forces this way and you have twisting in the joint, you have the lateral force up here, then in terms of the joint we have two actions at work there, and we have forces this way. But I say, to attempt to answer the question, I say that it's a question of the degrees of angles. And at some point, and again, I wish I had the mathematical ability to quantify, but it's all based on so many variables on what are the likely stresses or loads, what are the likely forces laterally, what is the size of the member, what is the strength of the member, what is the size of the mortise and the tenon, and all these sorts of questions come into play. So I have to confess, as a layman, I'm operating under a layman's, everyday workman's intuition about what works and doesn't work. And it seems to me I'm not violated structural concerns in comparison to millions and billions of chairs made, which the only difference being that these members were round instead of flat, angular, linear, rectangular type of components. And the round very often was not a through tenon, but was a ball and socket joint, or just a mortise, a round rail going into a drilled hole, and it's still effectively a mortise and tenon, but it didn't even go but partial penetration. And yeah, chairs do get lateral forces on them that are sometimes exceed what it was designed to do. Or another factor in this consideration is the quality of the fit, especially in hand mortise and tenon joinery. A drilled hole with a tenon tightly fit in a chair that did eventually fail. I just fixed one for somebody where a chair rung broke. It compromised the chair rung, and I never saw the vertical, but I assume they just handed me the rung and said, can you reproduce another one an inch longer? And I said, sure. So I lathed one for him and gave it to him, but I never saw the vertical, but I assume that the vertical did have some damage in the hole, and I made, under that assumption, I made my tenon fat. And sure enough, the lady called me and said, yeah, my husband put it right in, he glued it, had a little struggle getting it in, but he got it right in, and I had enough depth for it to work. And I'd like to see it because I would like to know if the round the vertical part of the chair, if the round hole was compromised down in this corner, picturing it racking around, and did it, redneck word is waller out the hole, or perhaps break off a chunk of wood. I would like to know that. And chairs and that can take inordinate stresses that I think it all has to do with the angles and the integrity of the joint in the first place. We know that other chairs made with similar or same angles and good fitting joinery have lasted hundreds of years, used as a chair, their intended purpose, not as a step ladder, not as a support for 1,000 pounds or something. You know, it was used as what it was meant to be, a chair. So, and they can last. So these are valid questions, though, about, you know, the use of a mortise and tenon on an angle. Where would it become compromised? And I look at the angles and the intended use of the piece and the integrity of the joint. Now, when we talk about the integrity of the joint, that brings up another question. At what point is the integrity compromised by the workmanship? And those are hard questions to answer, because if all we ever looked at was the anal pursuit of perfection, just anally pursuing perfection, we'll be very frustrated in any trade, especially in cabinet making. I think excellence is worth pursuing. You could even say perfection is worth pursuing, but I think we have to expect that we're not going to achieve perfection. What we should be talking with, and this is what the construction industry talks about, is we talk about standards. I'm going to put the camera back in the tripod, and we talk about standards. You know, if I set this here's a stool that's assembled, and you know, if I zoom in on a joint, let me see if I can improve this a little bit. Loosen this. And if we talk about a joint, here's a joint. It's probably not my best joint and certainly not my worst joint. If we talk about too much slop down the major glue surfaces of the joint, at what point do we cross a line in there and it doesn't have the integrity? I think that is what led, I'm guessing, but I think historically that might have been what led to pinning joints in the first place. Then we say, oh, we've got a mechanical integrity to it, that if the glue joint fails, we still have a joint. I'm guessing, but I think that could be what might have led to pinning joints in the first place. But when we look at joinery, at what point can this wall and the other wall, either of those, you know, at what point can these walls be too loose and exceed what the glue joint can do? And I think we have to be honest, and you know, the integrity of the joint is probably based on the integrity of the maker, that he sets standards, not perfection, but he sets standards about what was acceptable. And of course, as a business person, he's going to look at, is my buyer going to demand reparation, remuneration, or, you know, justice? And if it breaks, you know, am I going to warranty the product? Am I going to satisfy the customer? And all those things come up from a business standpoint. So, you know, this mathematics of money have motivated makers in the past to try to have good fitting joints, because it costs money to repair and fix and replace things. So, and there's embarrassment to your reputation, which is more important than than any one piece. But, you know, I look for a quality fitting joint that I didn't have to beat it together, because that's so hard in the process of making it. But it didn't just slop together either, because then I know it won't hold. So I look at standards though, and I guess it's subjective in some regards. You know, I'm going to take the camera off and show you some more joints, and then I promise you my joints are not all perfect. Here's a tiny gap here, and you would have to trust me when I tell you that the joint's glue surface is substantial in there, and it's tight and strong. And my problems on this kind of joinery, I guess you'd have to trust me on this, my problems center around the exact mouth of the opening. And I think I should do a video sometime on the mortising process, that so much depends on those starting entry cuts of the chisel making these mortises, but also delicacy in not, again, the redneck word is wallowing out that hole, not widening it and making slop in it. But even when you do, that tends to be right at the mouth of the hole. And there's good substantial integrity to the joint itself. There's another one. These are all, I'm showing you pretty good joints here, but I assure you they're not all perfect. Sometimes there's a cosmetic thing with a tiny chip out. Right there is one. So I think it'd be a good video on cosmetic improvements to these joints. Here's a little bit of a excess hole in the joint at the mouth of the hole, in this case at the top. And I have a trick for that. I think this is one I could tell you had that fairly pronounced. Under a 1/16 of an inch and yet dark, that jumped out at you and you saw it. And I drive a wedge of oak in there, cut it, and the end grain just blends in, it just disappears. I don't know if I can focus that close. But this is an example where I have yet to work on this joint a little bit to improve it. But if you could see, there's a tiny sliver of a wedge driven in to plug that tiny little hole, which is basically right at the mouth of the mortise. Let me see if I can find one on another piece. Right here, I did a dry fit. There's what I'm talking about. I will fill that with a wedged piece of oak, and the end grain, it will glue long grain to long grain. The end grain will get paired with this. When I pair this, I'll cut it off and pair it, but it'll get paired with it, and it'll virtually disappear, as this has. And there's even a little bit yet more I can do to here. So that would be a good video, looking at cosmetic improvements to otherwise sound joints. Here's a tiny gap right here, right in there, and that's all failure on my part to have a perfectly fitting top, perfectly top of the joints. Got a little bit of slop there. It could be one errant move with my chisel, you know, leaning against that wall with the chisel, levering against it. This is pretty good here. But that's the kind of thing I'm talking about. But I'm looking for tight shoulders so that those stresses are met by an opposing piece and not allowed to move and work and create more problems. So tight fitting shoulders are important to me. Not perfection, but substantial tightness. Clearly not perfect. Here's one that's not perfect. And I like to make my mistakes where they show less on the inside of the piece. And if both sides were like that, I would have worked on the joint more, because I can't tolerate too loose shoulders. But can I tolerate that in a handmade piece? Yeah, if I know the joint's good. And the joint is good. Here's one that I haven't dealt with cosmetically. What if you have, where like I said, a tiny bit of tear out, where you just get, where you gain in the size right at the mouth of the hole, where the chisel, working that chisel, and you tend to wobble this way, and that grows. And right there at the mouth has a compromise in certainly aesthetic perfection, but is there a compromise in the integrity of the joint or the standards I've set? No, I don't think so at all. And if this can't be filled, and there is such a thing as good fillers, and I touch them up with acrylic paints, then I do my finish, because I don't trust the stain to stain a filler. That just doesn't normally work. So I mix up a filler, either a 2-part or 1-part filler, put it in, I'll touch it up with my little acrylic artist paints to make sure it blends with the piece, and then go on and stain the piece. And you cannot see that. But I'm banging on the fact that I have an excellent fitting joint, and all I have is a tiny cosmetic defect, and to what extent then it shows I have to deal with that. Those are things I'm looking for, I said in my dry fit video. So this is just a few rambling thoughts. I hope this is somewhat addresses the question of angled mortise and tenon. When you get into problems, you know, this is a single rail. These have stresses on them, but that's why the attachment at the seat is important. So that gives me 2 places here and 3 places here, and that becomes important to this project, I think. But again, not from a true engineering standpoint, but from a practical workman standpoint. Thanks for watching.